All right, well, let's look at this example. This was an MCAT example. Consider the circuit. What happens to the total current if you add a resistor R as shown? What happens to the total current if I add this resistor here? And the total current, remember, that's the current coming here off of the battery. What happens to that total current? Well, first, let's ask ourselves the question, what happens to the resistance of this? What happens to the equivalent resistance of this branch? As I add resistors in parallel, the equivalent resistance decreases. So when I add this resistor R, the equivalent resistance of that branch is going to decrease. All right, now what happens to the current if my overall resistance decreases? Remember, V is equal to IR. The total potential remains constant, so that's not going to change. But I've already said now that my total resistance is going to decrease. So that means that my current will increase. Now, that might not be intuitive to you, but if I add this resistor, then the current increases. And we'll see, we'll work through some problems. You can actually calculate by how much that is. Let's do this example. This is a circuit that has both series and parallel. And we did similar ones with capacitors, but we're going to work through these, and then we'll sort of work up to increasing difficulty. I have two resistors. I want to know what is the equivalent resistance, and I want to know the voltage and current for each resistor. Okay, so first of all, let's just find the equivalent resistance of these two. I'm going to call that R23. They're in parallel, so it's going to be 1 over 3 plus 1 over 6, which is going to equal 2 ohms. All right, so that resistance is equal to 2 ohms. And then I'm left with a circuit that looks like this. I have a 1 ohm resistor and a 2 ohm resistor. And then to find the equivalent resistance, say this is 3 ohms. And let's see, I was looking at 12 volts here. Now, I want to know what is the, what did I ask for? What is the equivalent resistance and the voltage and current for each individual resistor? Okay, so first of all, I can find the total current, I. And the I current is going to equal to V over R equivalent, which is going to be 12 over 3, which is 4 amps. That means I have 4 amps coming off of this circuit. I have 4 amps coming here. That means that this current comes up and it goes through R1. So because of the way this circuit is configured, I, the total current, is equal to I1. Let's make a little table over here. I'm going to have V and I for each of the resistors, 1, 2, and 3. So I1 is equal to 4 amps. And then, since I know what I1 is, it's 4 amps, the resistance R1 is 1 ohm, so V1 is equal to I1 R1. That's 4 amps. I'm sorry, what was that? 1 ohm. So it's 4 volts. So 4 volts here. Now from here I can do a couple different things, and probably the easiest way for this one is I can look here. I have 4 volts across that resistor. Because of the loop rule, or the rule that says that for resistors in series, the sum of their potentials has to equal that of the battery, I have to have 12 minus 4, 12 volts, which is from down here, minus 4 volts from right here, equals 8 volts. So that resistor, that 2 ohm resistor, is equal to 8 volts. And then, because resistors in parallel have the same voltage, I have 8 volts across each of these. So I can put that in here. I have 8 volts across R2, and across R3. And then from that, I can figure out what is the current through each of those resistors. So I2 is V2 over R2. That's going to be 8 volts over 3 ohms, which is 8/3 amps. And then I3 is going to be V3 over R3, which is 8 volts over 6 ohms, which is 4/3 amps. So that gives me my currents, I2 and I3, 8/3 and 4/3. Now I can do a quick little check because I know that the current coming into these branches, I2 and I3, have to equal the current that comes into here. That is to say that I1 has to equal I2 plus I3. So let's just take the sum of these. That's 8/3 plus 4/3 equals 12/3 equals 4 amps. Whew. That checks. That's the same as the incoming current, which should be by Ohm's law. Right, that's a good simple circuit. All right, you could have some slightly more complicated ones on the exam, or you could have ones like this, or you could have both, which is more likely. Let's stop there, and we'll pick up with another example soon.